First we start off with the footing, which we dig that and reinforce it with 5/8 inch thick rebar. Once we pour that, we're able to form up the slab, which sets the perimeter of the home and lets us get started on the in-slab plumbing. Really, the in-slab plumbing is one of our first opportunities we have to start setting some of the performance and comfort characteristics of the home. Every home that we do features a circulated hot water system where it's got a circulating loop so you don't have a lot of wasted running water at the tap waiting for it to heat up. We insulate all our hot water lines underneath the slab, as well as sleeve everything so it's not in contact with cement. We make sure the hot and cold lines don't come into contact with each other so there's no thermal transfer occurring there. Once that's done, we can backfill and compact the slab. We fill it in, we dig in grade beams, as you can see through here, for reinforced areas that are spec'd out by our structural engineer. And once the slab is prepared, then we apply a chemical barrier that is designed to protect against subterranean termite infestation that might try to come up from underground. So after all that's done, that brings me to the first key item that I wanted to talk to you about today, and that is installing a sealed vapor barrier on the slab. That's what we're looking at right here. That's this blue plastic material that's down. And if you've been around construction before or seen houses being built, you've probably seen that thin, clear plastic visqueen that's typically used in new construction that's stretched across the slab as a vapor barrier. Unfortunately, that's pretty ineffective as a vapor barrier. It's too thin. It's the material that we're using here is nearly twice as thick as the code minimum standards require for a vapor barrier. And there's some simple reasons for that. One of them is durability. It's got to be able to hold up during construction. It's walked on. It's it's got to hold up. And if you try to have a plastic bag with a bunch of holes in it, it's not going to hold any water. Our goal here is exactly the opposite. We're trying to keep water from coming back up through the ground into the house. And if you've got a bunch of holes letting water come in, it's just not going to work. So what we do is we use a thick vapor barrier such as this. It's actually a class 1 vapor barrier. It's got a permeability rating of less than 0.1, which is very good. And then we come back and we seal the seams with this special red adhesive that you see here. Not only seal the seams of the plastic, but we seal around all the penetrations where you have plumbing coming up through the slab. That way you can control moisture before it ever enters the home. When you're managing moisture, which is the primary enemy in longevity and durability of a home, it's key to try to keep it out from the beginning. And this is where it starts, step 1, before you ever pour the slab. Side benefit of that is you can control mold and mildew that comes into the home. You have better indoor air quality. And a good vapor barrier such as this will actually prevent other harmful gases that can enter through the ground from coming into the home. So you don't have radon gas entering the home, you don't have methane, which also can be a ground source gas, and we can eliminate a lot of that from ever even entering the home. Once we have that vapor barrier in place, that brings us to the second key item that I wanted to talk about today, which is the post-tension reinforced slab. And that's what we have here. In fact, that's what we've done on every house that we do and have done for the last 10-15 years, simply because it is the best way of doing a slab on grade construction and provides the most benefit to the homeowner. Every slab that we do is designed by a structural engineer. They take into account the load of the home that we're going to build and place upon the slab. Then they calculate what load that needs to be supported by. They determine where the bracing needs to go, how much bracing we need, and give us a plan, and we can implement that plan so everything's supported. There's alternatives. Some people do what they call a structural slab or a steel reinforced slab, where they tie a grid of rebar together, and it's just not the same as where you have an engineer that's calculated your loads and telling you where to reinforce it. We are confident and can guarantee I have a 10-year structural guarantee that this slab is going to stay solid and how you need it to be. Rebar itself is a passive system. You just put it in the slab, it stays there. Steel post-tension cables is an active reinforcement system. Once the cables are put into place and stressed to the proper tension, again, as specified by the engineer, they are always under that same level of tension. So that's a big benefit to the homeowner. When you have a post-tension system such as this, You don't get the cracking and separating that you can get under a normal slab. You don't have lifting and separating, because even if you do get minimal cracking, it's held together by that tension on the cables. And this is just a huge benefit to the homeowner, and it allows us to confidently build on all different types of soil, whether we have soft soil, whether you have expansive soil like we can have in this region. We can confidently say the slab is going to stay put and hold up the loads that it was designed to do. So if you are building or buying a new home, make sure that you ask whether or not your home has a sealed vapor barrier and whether or not your slab is supported by an engineered designed post-tension cable system. I'm Ryan Farabough, and thanks for watching.